I'm Anil Kumar sharing with you solutions of 2017 trigonometry test paper. This is for students doing functions, advanced functions or pre-calculus preparing for university first year. We have 9 questions in this. I'd like you to pause the video, copy these questions, and then we'll take up their solutions one by one. Question number 1 and 2 are to convert from degrees to radians and from radians to degrees. Question number 3 is regarding arc length when angle and radius is given to us. Question number 4, we are given an engine which rotates with 9000 RPM. RPM means revolutions per minute, and we need to find angular velocity in radians per second. Question number 5 is to state similarities and differences between sine and tangent functions. Question number 6, we are given a transformed cosine function and we need to figure out amplitude, period, phase shift and axis. Question number 7 is to find exact value of given trigonometric ratios. Question number 8 is to find equivalent expressions in terms of related acute angle, and question number 9 is to sketch the cosine function given to you in question number 6. So I hope that's not very difficult. It should not take more than 30 minutes to solve this test paper. I'd like you to copy these questions, work it out, and then look into my solutions. Let's begin from question number 1 itself. At times, this paper is divided into 2 parts and you're not allowed calculator in one of the parts, right? So sometimes we break it up like that. Question 1 is to convert 450 degrees to radians. So the method is very simple. We want radians, right? So we have 450 degrees. Radians on top cancel out degrees. So it is pi radians divided by 180 degrees. So degrees cancel out and what you get is radians. Is that clear? You don't really have to remember this multiplication factor as some students try to do it. We can now divide by 9. 9 times 5 is 45. 9 times 2 and we get the exact value as 5 pi by 2, right? So that is the angle in radians. Now radians is a ratio. You may or may not write radians here. Is that clear to you? So if I don't write a unit, it means radians. Okay. Question number 2. Convert radians to degrees. See, we did not write radians here, but it is understood, right? So we have 7 pi by 4, and as you know, pi is equals to 180 degrees. So from here we have the multiplication factor. So we need degrees on the top. So 1 is equals to 180 degrees over pi. Think like multiplication by 1 is no problem, right? So that is also another way of looking into it, right? So 180 degrees over pi is 1 and pi over 180 degrees is also 1. Perfect. So that's how it works out. So we can just cancel this out, and 4, we can divide this by 4, no problems. 4 times 4 is 16, 20 means 45, and now you multiply. 7 times 5 is 35, 3, and 7 times 4, 28, and 3 is 315 degrees. It is important to write degrees in this particular case, right? Now let's move on to question number 3. Susie rides a camel on a carousel. The camel is located 12 meters from the center of the carousel. If the carousel turns through the angle of 8 pi by 3, right, which seems to be more than 2 pi, right? Anyway, so that is kind of the situation. It is turning, and if it moves along the angle of 8 pi by 3, we are given this is 12 meters. Determine the length of the arc traveled. So that is the arc, right? So 8 pi really means more than twice, correct? So pi 6, so this is like one full circle will be 6 pi by 3, right? 6 pi by 3 is 2 pi. And then if you see, that means one full circle, and then 8 means 2 pi by 3, kind of like this. So that much is the movement, right? Anyway, the question is very straightforward. What you should do is, you need to find the distance traveled, right? Determine the length of the arc traveled. So A equals to r theta is simple, where theta is in radians, right? So in this case, radius is given to us as 12 meters, and what we have in radians is 8 pi over 3. Since it says nearest to this number, we have to use calculator, correct? So we are not looking for exact answer, which is 32 pi meters. So we'll use calculator and figure it out. So it is 32 times shift pi, that gives us the answer in decimals. It is equals to 100.5309. Now we want it to nearest 10th, so you have to round it to 10th place, which is 100.5 meters, correct? So I hope that is absolutely clear. Now my suggestion is not to really work out what portion has been traveled. Use A equals to r theta and find your answer. So I hope things are absolutely clear till now. Let's move on to question number 4. Question number 4 is, the V8 engine rotates with 9,000 revolutions per minute. So we are given this number as 9,000 revolutions per minute. This is what we are given. What is the angular velocity of the wheel? So we want to find angular velocity of the wheel in radians per second. So we want omega, the angular velocity in radians per second. So basically we have to convert this unit, right? And round your answer to 2 decimal places, correct? So what we can do here is, we can write what omega is. So omega is 9,000. We are given revolution. Now one full revolution, that is one full circle, is how many radians? We know one revolution is equals to 2 pi radians, correct? So I'm going to multiply this by 2 pi radians and divide by 1 revolution. That is 1, right? So immediately I can cancel out revolution and I get radians in the numerator. Denominator is minutes. We want minutes to be in seconds. So as far as the minutes go, you know, 1 minute is equal to 60 seconds. Doesn't make sense, right? 60 seconds. So now you see how to convert units. So it's basically conversion of units. Revolution cancels, minutes cancel. You are left with radians per second. That is what we want. Perfect. That is what we want. And since we're talking about 2 decimal places, we don't really have to bother much about it. It is 3. So we could now calculate this as 3 goes 300. So it is basically 300 pi radians per second. And let's calculate. At times you may be required to find the exact answer, right? That's why I'm doing all this. Times pi, which is in decimals, equals to 942.477 is 942.477. Now 2 decimal places means up to here, so we'll round it to 942.48 radians per second, correct? So I hope that's absolutely clear. So when we are talking about angular velocity from revolutions per minute, it is basic conversion of units. Question number 5. State one similarity and 2 differences between the graph of sine and tangent functions, right? So you know what is tan x equals to, or tan theta? Tan theta is basically sine theta over cos theta, correct? Now that should give you some idea of how we can write similarities and differences. So as far similarity is concerned, how they are similar, both have same x-intercepts. correct? So for sine theta, you know, the x-intercepts are at n pi, where n belongs to integers. That is the similarity. As far as the differences are concerned, you could write many, right? So one of the differences is sine theta is continuous. Correct? Sine theta is continuous, and as far as tan, and we want two differences, so we can say sine theta is continuous, and its domain is, and the value of sine theta is between plus and minus 1. Is it okay? On the other hand, tan theta is discontinuous whenever cosine theta is 0. Is that right? Is or you can say has is discontinuous. Or let me write vertical as has. Let's say has vertical asymptotes. At what point? Whenever cos theta is 0, right? So cos theta is 0 for pi by 2, right? So we can say 2n plus 1 pi by 2, where n belongs to integers. Is it okay? So it is discontinuous. Perfect. The other thing is that we can say the range of tan theta is, it belongs to, I mean, you can say y equals to, we can say y belongs to real numbers, correct? So there is no restriction on range as far as tan theta is concerned. So that is how we can list out two very important differences between these two. Now I've added part B, saying state two similarities and two differences between the graphs of sine and cosine. So how are they similar? So they are similar in domain and range, in domain and also in range, correct? So that is their similarity. As far as the domain is concerned, when we say theta, then we can say theta belongs to real numbers. And as far as range is concerned, we can say y belongs to real numbers, where it is between -1 and +1, right? So these are important similarities. As far as the differences are concerned, you could write many differences, and major one will be about their x-intercepts, correct? So x-intercepts, they have different x-intercepts for both sine and cosine function, and at different values. You can say cos function is, or you can say y-intercept is also different, right? So you can say x-intercept and y-intercept are different. So for y-intercept, for sine theta, it is y equals to 0, and for cos theta, it is y equals to 1. As far as the x-intercepts are concerned, for sine theta, it is n pi, right? And for cos theta, it is 2n plus 1 over, n plus 2n plus 1 times pi by 2. Let me write, better is to write pi by 2, where n belongs to integers, correct? So that is how you can actually give their differences also. So I hope that makes sense, correct? Okay, so let's move on and take up question number 6. Now question number 6 is f of theta is equals to -3 cos of -2 theta plus 5 pi plus 1.5. State amplitude, period, phase shift, and axis of symmetry, right? Axis basically. Okay, so the first step is you should rewrite this function taking that -2 common. So when you do that, you get -2 and you get theta. When you take -2 out, you get pi by 10 with a negative sign. Plus, that could be written as 1.5. Okay. Now, as you know, cos of minus theta is equals to cos theta, correct? So with this negative, I could also write this as -3 cos of 2 times theta minus pi by 10 plus 1.5. Now, In ninth question, we have to sketch it. So that is the equation which I can use. Perfect. Now let's write down all the answers here. So A, the amplitude is how much? Amplitude is always positive values. Okay, so that is the amplitude A. And for B, period. So time period is 2 pi. We say time period is 2 pi divided by K, which is 2 here. So in this case, time period is pi. Phase shift. So C, which is the phase shift, is this amount. So phase shift is pi by 10 to the right, right? So it has moved pi by 10 to right. Do you see that? Now, if you do not factor, then you get a wrong answer. Do you see that? So if you do not factor, you will get a wrong answer. It is very important that to factor and then write the details, and you'll make mistake in question number 9, which is worth a lot of marks. Axis is this value 1.5. So let me write D. Axis is y equals to 1.5, right? Sometimes we also state here as vertical translation. So we can say vertical translation when you describe transformations by 1.5 units up, right? So that is how you could describe it. So I hope it is absolutely clear. So let's move on to the next question, which is question number 7. Question number 7 is to determine the exact value of each trigonometric ratio. Tan 11 pi by 6 and secant 3 pi by 2. So for exact, we will use special triangles. So I'll make two triangles here. One is pi by 3, pi by 6, 9, pi by 2. The other one is, well, we don't need pi by 4 triangles. So one is enough for us. So this angle for here is pi by 3, that is pi by 6. And the sides are in the ratio of 1 is to 2 is to square root 3, right? Well, I made pi by 4, but that is not required since it is pi by 2 here, okay. So let's do tan 11 pi by 6 first. Now what is tan 11 pi by 6? So there are two steps to give you the exact value. I would like you to understand and then follow this method. So when we say 11 pi by 6, that means this pi has been divided into 6 portions, right? So pi has been divided into 6 portions. So this up to here, it is 6 pi by 6. So when you go back to this place, it is 12 pi by 6, correct? So of course, 11 pi by 6 is going to be 1 less than this, right? So we are kind of here. So this is 11 pi by 6. So that is the principal angle, 11 pi by 6. Does it make sense to you? Correct? So that really means that we are in quadrant 4, correct? So we are in quadrant 4. This is quadrant 1, 2, 3, and 4. You know the rule, right? So all students take calculus or cost rule. So in quadrant 4, tan is negative. Perfect. So we'll write here, it is equal to negative. Since we are in quadrant 4, is it okay? Now we check the acute angle. So acute angle for us is, it is 1 less than 12, 11, right? So it is pi by 6. Acute angle is pi by 6. So it is minus tan pi by 6. Does it make sense to you? That is how you're getting equivalent trigonometric ratio. That is first part. Now we'll look into this triangle. Tan is, you remember, SOHCAHTOA over, right? Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent side. So if you look from this side, which is pi by 6, 1 over square root 3 is your answer. So you get minus 1 over square root 3, correct? Some of you may write this as your answer, but I'll prefer that it is rationalized. So the idea is rationalize. So when you rationalize, you will get tan 11 pi by 6 as equal to minus. You are getting 1 over square root 3. You have to multiply and divide by square root 3, correct? So you get minus square root 3 over 3 as your answer. So that becomes the answer for us. Perfect. So that is how you have to give the answer. So I hope the steps are absolutely clear. Okay. Now let's look into the second one. Secant is reciprocal of cosine. So we can write this as 1 over cos 3 pi by 2. Correct. So 1 over cos 3 pi by 2. Now 3 pi by 2. How do you know this value? The exact value, we don't have a triangle for this. Well, what we can do is we can sketch the cosine function, and we know this is 1 pi by 2, 2 pi by 2, 3 pi by 2, and then this is 4 pi by 2, right? So that is 3 pi by 2. Is it okay? So for cosine function, it is at 3 pi by 2. You can clearly see it is 0. So what we get here is 1 over 0. So it is not defined. So it is not defined. So this value is not defined. Does that make sense? So you get 1 over 0, right? So that is the cos function. So it is 0. So 1 over 0 is not defined. So secant 3 pi by 2 is not defined. So it does not have any value, correct? So that is a vertical asymptote for the secant theta. I hope that makes sense for you. Perfect. Okay, so let's move on to question number 8 now. Question number 8. State an equivalent expression in terms of a related acute angle, right? So related acute angle alpha is always between 0 and 90 degrees. Is it okay? That is related acute angle. We are given sine minus 7 pi by 6 and cotangent 7 pi by 4. So let us see how to do the first one. So we'll do it in 2 steps again as we did the previous question. First is to locate the quadrant in which it falls. 7 pi by 6, that means, and negative. Negative means we are going to move in this direction. Is it okay? Now if you go in this direction, this is 6 pi by 6. One more will give you 7 pi by 6, correct? So that is 7 pi by 6. So what is the acute angle here? 1 more than 6 pi by 6. Is it okay? So it is pi by 6. Now in this particular quadrant, sine is positive or negative? In this particular quadrant, sine is positive, correct? So you know the rule. So all students take calculus, sine is positive. So we are looking for a positive answer. Is it okay? And therefore, we could write this as equal to, let me write here, big and bold, sine of pi by 6. Do you see that? So that becomes the equivalent expression for the given trigonometric expression, correct? Now let's do the cotangent 7 pi by 4. So now here again we'll do 7 pi by 4. That means the pi is divided into 4 portions, and 7 means it is kind of like this, right? So here, right, that is 7 pi by 4. So this is 7 pi by 4. Now in this particular case, you are in quadrant 4, correct? And in quadrant 4, you know cot is negative, right? So cot is negative. So what we know here is that rule is like this. All are positive. Sine, tan or cotangent are positive here. Cosine or secant is positive here. So we are looking for a negative answer. And what is the acute angle? Acute angle is pi by 4. So I could write this as cot pi by 4. This is clear, right? So this is pi by 4. So that is how simple it is. So step number 1, locate the quadrant. Step number 2, find the acute angle. Quadrant gives you the sign, positive or negative, right? So in this case, it was positive quadrant, correct? And the acute angle, just replace the angle with the acute angle. Does it make sense to you, right? So that is how it should be done. So it's not difficult at all. And when I was writing this, radians, we will write pi by 2 here, right? Now, strictly speaking, it is between 0 and pi by 2. Perfect. So let's move on. And the last question is on sketching. Let's do that. Question number 9. Sketch graph of f theta equals to minus 3 cosine minus 2 theta plus pi by 4 plus 1.5, where theta is between 0 to 2 pi. So we had this earlier also as question number 6. Now we are going to sketch this particular function. First, let me rewrite this function in a very familiar way, right? Which is, we'll factor out minus 2 and then we get theta minus pi by 10 plus 1.5, correct? And since we know that cos of minus theta is equals to cos of theta, I could now write this function also as equals to minus 3 cos of 2 times theta minus pi by 10 plus 1.5. Now to sketch this function, I will apply two different methods. So one is transformation of points. Okay, so we'll take up the key points, transform them, and then get the graph. Now I'm not using any graph paper. Normally in the test you will be given a graph paper, correct? So as far as the cosine function is concerned, let's say cos theta, the key points which you have to look into are the cos function starts with 1, right? So it is 0 and 1, and then it is pi by 2 and 0, and then it is pi and it goes to minus 1, and then it's 3 pi by 2, and then back to 0, and at 2 pi it is back to 1, right? So that is the cosine function. Now in this particular case, you can clearly see the transformation. The x values are getting divided by 2, and then you have to add pi by 10. So the x values, which are the theta values here, so what you do here is, so this is like theta and let's say y is okay. So now theta becomes theta divided by 2, and you have to add pi by 10, correct? So that is how the theta value changes. As far as the y values are concerned, you do negative 3 times the y values, whatever you got here, and then you have to add 1.5. So that gives new coordinates, or we say the image. Is it okay? So this is the calculation which you have to do. So for 0, if I write 0 here, now for some students that could be very difficult or challenging. So what I will do here is, I have to sketch the graph also, but what I will do here is I'll show you how to calculate them. For 0 it is simple, just put in 0, you get pi by 10 here, perfect, so pi by 10. And if I write minus 1, so I get minus 1.5. So that is the first point. Now if it is pi by 2, then how do you do it? So let me show you the work here, as I have seen some students struggling. So first we will do theta by 2. So pi by 2 becomes pi by 4. So let me do it here. So we get pi by 2 because we have to first half it. So it becomes pi by 4. And then we have to add pi by 10. Do you get it? We should have common denominator. In this case, 20 is the common denominator. So 4 times 5. So we get 5 pi plus 2 times pi, so we get 7 pi by 10. Do you see that? 7 pi by 10, 20, sorry, 7 pi by 20. So this is 7 pi by 20. Is it okay? Now if it is 0, we get plus 1.5. So that's the next point. If it is pi, in that case, first we'll do half of this and then add pi by 10. Common denominator is 10. So it again gets multiplied by 5 plus 1, and both are pi's, right? So 6 pi by 10, which could be simplified and written as, if you divide both by 2, you get 3 pi by 5. Is it okay? So this is 3 pi by 5 for us, right? So it is 3 pi by 5 minus 1. Minus makes it positive 3, and then you add, so you get a maximum value of 4.5. Correct? 3 pi by 2. So 3 pi by 2 makes it 4. Add pi by 10 and 20 is your common denominator. So 5 times 3, 15 pi plus 2 pi. That gives you 17 pi by 20, right? So we get 17 pi by 20 in this case, and 0 corresponds to 1.5. As far as 2 pi is concerned, 2 pi first divide by 2, and we have to add pi by 10. To get 10, we got to multiply both by 5, correct? So 5 times 2 is 10, to get 10 pi plus pi over 10, which is 11 pi by 10, correct? So we get 11 pi by 10, and this is 1 corresponds to minus 1.5, correct? So these are your values. So on a graph paper, you can write down these values and plot the graph. Is that clear to you? Now let me show you the method which I normally use. Okay, so we'll go back to question number 6 where we calculated few things. So we'll start with axis. So we have axis which is 1.5. We have amplitude A which is 3, and we have time period T which is 2 pi by 2, right? 2 pi by 2 is pi. So pi is the time period for us. That is to say, we expect 2 cosine waves in this interval, right? This is 0 to 2 pi. You get the idea, correct? Now, let's try to sketch it. In the graph paper, these are the points which will give you the result. So your job is actually done here. But let me show you how we could do it without calculating these points, correct? That's kind of critical to understand, and a preferred way of doing things. Okay, so we normally begin with the axis which is at 1.5. We also saw the maximum value is 4.5. So let's say this is 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. Okay, so we'll draw a dotted line for axis at 1.5. So this is 1, that becomes the dotted line at 1.5. Perfect. Now, maximum value is 3 more. So from here, so it is 1, 2, 3, 4, 4.5, 3 more. Right? This is your maximum value. So it'll go up to here, and 3 less, right? So the minimum is 3 less than the axis, which makes it to minus 1.5. So this is 1, this is 2, so somewhere in between, that becomes minus 1.5. So I usually use 2 steps to sketch the graph. In the first step, we will do without phase shift. Is it okay? In the first step, we are going to do without phase shift. So what we are going to sketch first is the graph of minus 3 cos of 2 theta plus 1.5. So cosine starts with maximum, and let us say, let me just sketch here roughly what is pi for us. I want to finish it here. So let's say this is 2 pi. Okay, so in that case, this is pi for us. Okay, and this has to be divided into 4 equal parts. Right, so, okay. So 4 equal parts, right? So 4 equal parts. Okay, so what I'm saying that this is 2 pi. So we get, and the half of 2 pi is pi for us. So 1, 2, 3, 4. So 1, 2, 3, 4. This is pi for us. Is it okay? And we divided this into 4 equal parts. So the cosine wave basically starts with the maximum, right? First part. And then it comes to the axis. And then it goes to the minimum. And then again, it comes back to the axis and goes to the top. So what we get here is your first cut at my function of cosine. This is one wave, correct? And this wave actually repeats. So 0, minimum, in between, and the maximum, right? So this is what you get as your cosine function without phase shift. Is that okay? Now we are going to sketch f theta, which is with phase shift. So now we'll sketch minus 3 cos of 2 theta minus pi by 10 plus 1.5. Is it okay? So this is pi for us, this is pi by 2, this is pi by 4. So let us say that much is pi by 10 for us. This is pi by 10. That means I have to shift each point pi by 10 unit to the right. Does make sense to you, right? So I'm shifting every point pi by 10 units to the right. Once I do that, then I get my function, which is kind of like this, right? So this is my final graph. Is it okay? So we go up to this point. So at that will be 2 pi plus pi by 10, right? So if I do 2 pi plus pi by 10, so it goes up to 2 pi plus pi by 10, so 21 pi by 10. Do you see that? And starts from pi by 10. So basically it ends kind of here. So that becomes your f theta, and this is theta here for you. So that is the exact value which I could do without calculating. But if you're sketching on the graph, you will find these values will perfectly match, and that is what you're going to get. So I hope you have understand and appreciate two-step method for graphing. This is your two-step method, right? Two-step method. And also the points, the image points. Both are very good methods to sketch any trigonometric function, and I hope that helps. Thanks for watching, and I hope you have learned from this video. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'll be great. Thank you and all the best.